And now this is the best part. I love doing this. Now you drag the handle and now you see, start dancing. You see the geometry in Rhino? I know this is kiddish and silly, but I really like doing this. And you see, start dancing. And the way you take any particular graph, the geometry will keep on dancing. Okay. Hello everyone, welcome back to my channel. I am Kedar, and today's video will be a continuation of my previous video where we looked at creating 2D patterns inside of Rhino using Grasshopper, where basically we started by creating any grid pattern and using an attractor point or a curve, we scaled them. And first, without using remapping of numbers, so we got something that was overlapping, and then we used remap numbers so that we don't get this overlapping patterns. And once this Grasshopper script was totally finalized, we changed the original input geometry, for example from square to triangle, we used hexagon and things like that. And once we were okay with the entire pattern, we then baked the pattern inside of Rhino, removed some of the pieces that we felt were not okay to create more dynamic facade and converted the same pattern into a 3D object. And in today's video, we will continue this by looking at two concepts. The first is looking at a component called graph mapper inside of Grasshopper, and second, once we have created all these 2D patterns, we will see how to morph them on a 3D surface, converting them into a 3D pattern. Okay, so let's see what graph mapper does and what this component is all about. And I'm going to become small so you can see my entire screen. So basically, when you take a component graph mapper, it basically allows you or gives you freedom of using a lot of graphs. And this is directly transformed or directly imposed on the geometry. So for example, let's say you take a series of points, those will move using graph mapper as a reference. And I've selected a few of the examples which use graph mapper. These are again from architecture specific, but you might find use cases of graph mapper everywhere. For example, this wave structure facade designed by Scott Brown Rig Architects is basically a car parking facility. And if you see, the facade has this wavy form to it. And the graph mapper, if you see, is kind of using this kind of a graph where whatever the lines are there are moved using this particular graph. And then the other example is this project called The Couch designed by MVRDV Architects, where basically is a multifunctional tennis clubhouse. Like you can see the people playing tennis here, and whatever this kind of an arc you get is by using a graph mapper. And the one that I think they have used graph mapper is this, so that they have used the reverse of this in the front and then the same one at the back end, and in between they have sliced it out to create steps for people to view the tennis game. And the next project is this winery designed by Santiago Calatrava. Now this is a little bit unique because I think they have used two graphs to do it. The first one is this same kind of a sine wave which gives this kind of a pattern, and you see the center one is kind of at much more elevated and it's much more coming towards us. So I think they have used this graph as well. So you can also combine graphs to create any particular design. You don't need to stick to only one particular graph. And the next example is what I have done. So basically sometimes I like to extract parameters from the nature and kind of make it into a space. So I called it creating natural parametric systems. So looking at ripple pattern that is created when a water drop falls on water. And for this I used this particular graph. So you see at the peak, it kind of goes up and slowly it diminishes and becomes flat. So that's what this ripple uses a graph mapper. So there are a lot of ways that we can use graph mapper. Now let's see how do we actually work with this. So if you take this particular component, the first time it will be totally blank. What you need to do, you need to right click on it, go to graph types, and you can select any of these graphs that are available. I generally like to use sine, but you are free to use whichever you want. But there is no output from this component. So you will see if I connect a panel to this component, it says no data was collected because graph mapper as a component needs numbers and then it gives out also numbers. So you cannot really connect any geometry. You can only give it numbers and you will get output as numbers. And you will see in the output, the minimum is 0 and the maximum is 1. And why is this? So if you remember during our school days, we worked with graph sheets where we created a vertical and a horizontal line, and there was a minimum somewhere here and the vertical and the horizontal kept changing. So similarly, the graph mapper works the same way, where here you will see the minimum is 0 and the maximum is 1. And on the graph mapper, you will see it says 0:1, 0:1. That means the minimum is 0 and the maximum is 1. And of course, you can change these limits. So you can double click on Graph Mapper, and then you can change here what is the minimum you want or what is the maximum that you want. And then you can press OK. But for the sake of this video, let's keep it simple. Let's not make things over complicated, because then we have to constantly multiply things, and I don't think like adding unnecessary mathematics is good for learning anything. So let's keep it simple. Let's keep the limit 0 to 1. And now let's see how this Graph Mapper component works. So for instance, let's say that I take this value, which is 0.7, and now you will see the output says 0.079. And why is this? So this is because the way Graph Mapper works is whatever number you input, it first goes on this axis, then it goes vertical, and wherever it intersects, it gives us this output. Okay, so basically, let's say this is 0 to 1, and this is divided, if you see, in 10 parts. So each part is 0.1. So my intersection is somewhere here. So 0.1, 2, 3, 4, 5, 6, 7, 8. And this is closer to 0.8. That's why the number is 0.79. So that's how Graph Mapper works. Whatever number you add, it goes first in this direction and then vertical, and then wherever it intersects, it gives us the particular output. And it doesn't need to be 10, it could be hundreds of number or thousands of number, doesn't really matter. And each Graph Mapper component comes with handles. So you will see here, it has 2 of the handles, and you can move these handles to change the way the graph performs. So if I move this handle, you will see I get a different type of graph. So this is still kind of making a sine wave, but by moving, I can create multiple or more sine waves. Again, the limits we have not changed, they remain 0 to 1. So now in this case, if I take 0.5 value, this has become 1, because you see at the middle, the intersection is at the top where the limit is. So it again goes in this direction, goes to 0.5, which is the middle of the graph, then goes vertically, and where it intersects, it gives us the value. So in a sense, that's how Graph Mapper works. And of course, you can remap values as well. So let's say you don't want the limits to be 0 to 1, you want it 2 to 5. So whatever output you get from Graph Mapper, we can always remap it. So for instance, what was 0 will become 2, and what was 1 will become 5. But you will see that 1 is here and 5 is here. That is because it's the influence of the graph. So you have to be a little mindful when you use a Graph Mapper. You will not see the maximum directly here, maximum, because the graph is intervening or changing the numbers. So actually at 0.5, I'm getting the maximum value, which is 1, because we use Graph Mapper. So the 1 here becomes 5. Okay, it a little bit takes time to understand, but basically whatever numbers you add in, Graph Mapper changes those depending on the graph that you have used. Okay, so that's basically what Graph Mapper does. Now let's see if we have an example. For example, I have a long series of points and I want to move them using a Graph Mapper. So like I told you, Graph Mapper does not take any geometry. So if you put a curve, surface, geometry or anything, it will say that could not map values of type mesh. So basically it only takes numbers. But luckily points are numbers, in a 3-dimensional space. Points have an x, y and z coordinate. Okay, there are multiple ways of using any component in Grasshopper, but for this particular example, because we are doing and working with attractors, I think this is the workflow that we will be following. So like I said, each point has a x value, a y value and a z value. For example, there are a series of points which are like the second point is 10, 0, 0, which means it's 10 in x, 0 in y and 0 in z. Or for example, this point is 10 in z, 10 in x and 10 in y. So every number or every point has 3 digits associated with it. But if I would directly connect these numbers, you will see what happens. You see, Grasshopper gives me the output 0, 0, 0, 0, 0. And why is this? This is because these numbers are becoming bigger than the limits, because the limits here is 0 to 1. I know this is little bit getting complicated, but if you want, you can pause, but I'm trying to tell it as simple as possible. So whatever number it is, because it is crossing the limit, it is becoming 0. Okay, but we can always remap the numbers as well. So what I do is I remap these numbers. So I say whatever is the maximum, let it become 1, and whatever is the minimum becomes 0. And now it's easy for Graph Mapper to plot these points and give us a value. Okay, because now it fits in the limit of 0 to 1. Okay, like I said, you can double click on Graph Mapper and change the limit, but I prefer this so that I visually see what numbers there are, and I always like to move number in the number slider, and then it remains the same. So whatever numbers we get, last time we saw how to scale it, here you can multiply it and move them. So these numbers I will multiply by some higher number, let's say 100, and I move these points in y direction. So now the maximum is 100 because I multiplied with 100. So the limits now become 0 to 100. How? Because multiplying 0 by anything becomes 0. So this remains flat, and the maximum is going to be 1. So multiplying anything by 100 into 1, we are going to get 100. So we end up getting this particular graph. Okay, I will show you how to do this. But in essence, that's how Graph Mapper works. This Graph Mapper and Grasshopper are too close. In video, if I sometimes say by mistake Graph Mapper instead of Grasshopper, please forgive me and understand. Okay. So, but whenever you take any particular Graph Mapper, you change it to whatever value you wanted, you add numbers, you get numbers, and once you have numbers in Grasshopper, we are golden. We can change it to whatever we want. We can use for scaling, moving, and things like that. Now let's see how to use Graph Mapper to create patterns, and also how we can change our patterns that we created in the previous video using this particular component. Okay, so I have opened Rhino Grasshopper. I have taken the same script file that I have generated in the last video. So the first thing I want to do is I want to create a line, and using Graph Mapper move it. So let me go to top view inside of Rhino, and I'll make a line inside of Rhino. So I type line line, and then I will say 0 on my keyboard. So it starts from 0, and then wherever you want it to be the end, you can specify the end point. And if you hold shift, you can create straight line, or you can on ortho here. Either way, it's fine. I'm going to hold shift so I get this straight line. Okay, so I created a line, super simple. Then I want to take this line inside of Grasshopper. So I go to params, geometry, I take curve, right click, set one curve, take this curve inside of Grasshopper. And then I can't directly move this line into any kind of graph. I need to convert them into points first. So I go to curve, division, I say divide curve. Now here I will need what is my curve. So I connect curve to curve. And right now, whenever somebody made the component, they added the preset value to 10 of points, and that's why you see there are 10 points. I want to increase this, so I say 25, and I connect 25 here. And if I take a param input panel component, you will see all of these have 3 values, which is what is the x coordinate, y coordinate, and the z coordinate. Okay, so we can take Graph Mapper. So I go to params, input, we take Graph Mapper, I right click on it, I go to graph types, and I will say sign. You can change whatever graph you want later on as well. And if I directly connect the points to the Graph Mapper, and let's see the output from the Graph Mapper. So here the domain you see 0 to 1. If I double click on the Graph Mapper, you will see it's x is 0 to 1, y is 0 to 1. Okay, and if I take the output, for example, you will see the output is not really following the curve, because the 25th point should be 1, but the highest point is somewhere in between. You see it's 0.85 or something like that. So that's why we need to remap numbers. Okay, and I again want to stress that there is no one script that works for all. It depends on the way that you have been working and what output you want. So for us, the target is that we can use this script inside of Attractor. So that's why remapping comes handy. But let's say you had 10 boxes, you would not use this script, you would use some other script. So with Grasshopper, every script kind of changes, and it depends on what you want the output to be. Okay, so I'm going to remove this using control on my keyboard and then remap these numbers. So we go to math, domain, we say remap all of these numbers. Then we need to feed it what is the minimum maximum. So we go to bounds, we connect the points to the numbers, and then we connect the domain to the source. Okay, and then we need to add what is our new domain. So I go to math, domain, I say construct a new domain, and right now it is between 0 and 1, which is fine. And this mapped values I will connect to the Graph Mapper, and let's see the output. So I go to params, input panel, and now you should see that the base point is 0 and the last should be 1. So now it is following this graph. And if I change the graph little bit, let's say I move this handle, something like this. So the end point becomes almost 0 and somewhere in middle, which is like 13th or 14th, I think. Yeah, these becomes 1. Okay, because that's the mid of it. Ideally it is 12.5, but somewhere in between we get the highest value. So that means that this particular graph mapper is performing correctly. Now using these values, I want to move these points to create a graph. I go to transform, Euclidean, and you see there is a move component here, which is super simple to use. It has only 2 inputs. One is what is the geometry you want to move, which are the points, and what is the motion, which is X, Y, or Z. Now in this case, I want it to move in Y direction, as you will see here. So then I go to vector, I say unit Y. Okay. Now this is very simple. It basically asks you what is the distance that you want to move. Now my distances are coming from panel, and I connect the unit vector to motion, and now I need to connect the points to geometry. What I can do is I can connect the points here, and I can double click on this wire to make it into a relay so it looks nice. And now you will see the points have moved. Amazing. Super nice. But the distance is less, right? Because the length of this line, let me check how much is the length. Let me take distance. Yeah. So you see the distance is around 120. So I need to multiply this by some number. Okay. So what I will do, I will remove the panel and factor. I will move this little bit to the right, and I will add a multiplication factor here because I want the points to move substantially. So I go to math, operators, I say multiplication. Okay. If at any point of the script you feel like what am I blabbering, you can always comment and ask me. I will be happy to answer any questions that arise. Okay. So I connect the panel to A, and then B, let's say it's 120. So I keep it 100, and I can always reduce it. So I multiply by 100, and now I connect that to factor. And now you see whatever the graph we had is now the points are moving that way. Amazing. It's too big. Let me make it 50. Yeah, this looks nice. And to get back or to convert these points into a curve again, I will go to curve spline. I say interpolate, which basically connects the curve and gives you a smooth curve because you can add degree here. So if you want to get a sharp curve, you say degree 1. If you want to get a smooth curve, 2, 3, or 5. And periodic, right now there's nothing because this is used generally if you want to get a closed curve or open curve. So I connect the geometry to the vertices, and now I get my curve back. So we have transformed a straight line into a curved line using a graph mapper. Yay! Amazing. Okay. So I'm going to preview all of this off. Actually, let the points be on. So I'm going to, okay. And now this is the best part. I love doing this. Now you drag the handle, and now you see it start dancing. You see the geometry in Rhino? I know this is kiddish and silly, but I really like doing this. And you see it start dancing. And the way you take any particular graph, the geometry will keep on dancing. Okay. Now, if I move it more, now you see it's become this jagged kind of way. It's not doing a smooth curve. In that case, what I can do, I can increase the points. Okay. Because you have to understand that each point has to connect to one another. So this is again comes the part of NURBS where it is not uniform. Okay. Sometimes it's helpful. Sometimes it's not. In this case, it's not helpful. So what we can do, we can increase the 25 to let's say 100, and now we get amazing result. So now you can play with it. I can right click, I say graph type, I can say sync, and now you will see whatever I do gets transformed here. And how cool is this? This is brilliant. This is a geometry and I can 3D print it from just a graph. I don't know how else to express this. Or whatever, let's say I go to Bezier curve, and then I can use this handle. I can use this handle. Amazing. Okay. And again, this all is changing depending on the values that we have. So if I reduce this to 1, you will become the graph becomes flat. Here the graph becomes more. Let's go back to the dancing sine wave and let's move it back. So let the dance happen again. How beautiful is this? How beautiful. Okay. So that's the basic of how graph mapper works. So you use any number into graph, you output that number. If you want to simply move, use multiplication. Okay. So now I will group this and then we will see how to use this into a attractor script that we did. Okay. So I'm going to copy this script that we created. I'm going to say Control C, Control V. Let me copy this here. Okay. And the script was very simple. We started with a simple square grid. We need to scale it using an attractor. So we made a curve here. We used a component called pull point to pull all the midpoints on this particular curve. And then we looked at what is flat and graphed. And then we remapped them depending upon the scaling factor. And then we got this particular output. Right now, I will on scale and I will disconnect this boundary surface because generally surface takes a little bit of time to create. And it's really important to see which component is doing fast and you work with that, then wait until the end because you can always disconnect and remove and connect again. So now let's see where graph mapper comes in. Okay, so ideally the graph mapper sits here. So we remove the factor from this because now we want the influence of the graph mapper. Okay, I will take graph mapper. I connect this to the mapped values. I will right click, say graph type. I say sign and connect this to a factor. And now let's see what happens. Does it move? And you see there is a movement happening to it. How cool. So now you see because of the graph mapper, the influence is there. Okay. Right now it is becoming big and small, but I love it. And you see this is, so you can imagine this is a going up, going down, going up, going down, going up, going down. And how many times? 1, 2, 3, 4. 1, 2, 3, 4. And I have no words to express. Okay. I can right click. I can say graph type to, let's say, Perlin noise, or whatever graph type you will take, it will do the job. And whatever the same script, only thing you had to change was this mapped values, which was going to scale, and you get this graph. Okay. And this is, like I said in my previous video, this is another way to add dynamicness or make the patterns much more fluidic. I can right click. Let me go back to my sine wave and then let me now connect it to boundary surface. And now you can also change, like I showed in the earlier video, the attractor. So if I make a circle here, circle, I just say right click, set one circle, and now the pattern changes. And I can make this big, hold shift, can make this big or small. And the pattern again is following graph mapper. If I don't use it, so if I directly connect the mapped value to scale, you see it's just going to do one thing. Now here, if when I add a graph mapper, it's going to create this kind of a ripple effect. The other thing that you can also do is you can change these numbers. Okay, so for example, right now it's 0.1. I'll double click on it and I will make this digits to 2. So I get one more digit after the decimal, again number to 2. Okay, and now I can reduce this. So if I want, I can reduce this, and this kind of goes back to the original, and this is the final result. Okay, so this is, you can use it if you are animating it and things like that. You can screen record it, so you can move it and create this kind of an animation. Of course, you need to add a display preview in the end, custom preview. So once you create the script, the possibility of iterations is limitless. Okay, now any pattern that you have done, you can use graph mapper there. For example, so I remember I had created an hexagonal or a triangular pattern as well. It's the same pattern. You can just simply put graph mapper here. I'm gonna copy this, connect this here, connect that here. So now you will again see the influence of the graph mapper on this particular output. So if I move this, and you can change whatever values you want. Okay, so this is super simple and kind of adds a layer of control to the attractor point, which sometimes can be a little bit of flat because it only works with flat 2D patterns. I like to add graph mapper to add a layer of detail or a layer of complexity to it. Now let's see how to create this particular image. Let me bring it on screen. Okay. So here, if you can imagine that there was an attractor somewhere here like this. I think it was like a diagonal. Okay, and the waveform kind of goes like that. So it goes down, up, down, up, down, up, and so on and so forth. Okay, so it's kind of creating using an attractor. The principle and the logic is super simple. The process here is a little bit different. So first what we need to do, we need to create, okay, please imagine this as very sharp vertical lines. We need to create series of vertical lines. Then each one line, so let's take this line here. So we take one line and we will divide this into number of points. Then using graph mapper, we move these points somewhere like that. And then we join the points again. So it's kind of combining the first script that we did today. And then we get something like this. Okay. But we don't want this. We want influence of an attractor. So then we add an attractor here. And then we will see how to move this. So basically the wave pattern kind of becomes here. This becomes flat and the wave pattern becomes here. And then the wave pattern goes whatever the way the attractor point is, okay, or the attractor line is. So that's the logic that we will follow for this particular example. And now let's see how to do that. First we go to curve, we go to primitive, and then we say line SDL. Okay, again there are various ways. If you feel comfortable making line in Rhino and then taking it, absolutely fine. My job is to show you as many components as possible, and that's what I'm doing. So this particular component has three inputs, which is what is the start of the point, what is the direction, and the length. Okay, so let's say the start of the point is at 0, 0, 0. If you want to create a point at any coordinates that you know, what you can do, you can double click on the canvas, you can type 0, 0, 0, and it will create a point there. And now you will see there's a point here. Or if I say 50, 0, 0, I get a point here. Okay, so that's a easy way to create a point rather than creating a point and taking it. I generally like to type the coordinates of it. So I say 50, 50, 0, and then you get a point here. Amazing. So I connect the point to the start, and the direction I want is in Y. So I'll go to vector, vector unit Y, and then you can specify the length of the line, curve, whatever you want. So let's say the length is around 1000, or let's say 1200. I generally don't like to keep things to 10 and hundreds because then I have to double click on the slider and again move it. Now we need to create copies of this. So what we would do, I can move this. Okay, so if you're watching it, please don't continue. Okay, what am I saying? You can always pause it. Okay, I constantly keep teaching online on Zoom, so it's very difficult for me to realize, okay, nobody's doing it live with me. So you can do whatever you want. So I can go to transform, Euclidean, I can say move. Okay, and now I can add distances here. So let's say I go to vector, I want to move this in X. So I go to X direction and I will add values here. So I'll create a panel and then I will say move it by 10, 20, 30, 40, 50, 60, and then connect it. And now you get this 6 lines. Okay, but this is not the correct way. I will tell you why. But whenever you are starting and working with Grasshopper, try to use whatever you know. It might sound dumb in the beginning. Okay, I know that I used to create like this earlier when I began, and then I would research. Right now, of course, there's ChatGPT and things like that. But then I would research, okay, I have done this. How do I make it small? Because this to me doesn't feel parametric. For example, let's say the spacing, I want to make it 50. Do I need to again double click and write everything? No, that's not correct. So I would always go on the internet and then check. But the point that I'm trying to make here is that whenever you are beginning, you will make these kind of mistakes. They're actually not really mistakes, but these are because you don't know and you have a limited understanding of Grasshopper. But keep on going, keep on seeing what you can do. Then you can always ask somebody, okay, this is how I have made. I don't think this is parametric. Can you tell me a component that can resolve this? Okay. And for this case, there is a component called series. So if you go to, it's under set, sequence, and the component is called series. So what this particular component does is basically it asks you what is the start, what is the step. So whatever in this earlier example was 10, what is the gap you want and how many number you want. Okay. So I will say the step as, maybe 100 between the lines and how many ever lines I want. So let's say I want 12 lines. So I say 12 and I connect the count here. Okay. And now if you see the output of series, if I go to params, input panel, the start is 0, then 100, 200 and so on so forth until 1100. Again, why? Because the start is 0. Okay. So this is much more easier rather than me every time typing. So like next time I feel like, okay, the spacing between the lines need to be 50. I can just change this number slider rather than manually calculating every time. Okay, so I connect this to factor and now I get 12 lines. Amazing. Okay, I need to motivate myself making these videos. So sometimes if I shout, please don't mind. And then I'm going to preview this off. So let me preview this off. Let me preview this off. Okay, then like I said, we need to divide this. So we go to curve, division, then we say divide curve. We divide all of these. Okay, and then we need to add an attractor point. So I make a curve inside of Rhino. So I'll just make a line here somewhere, something like this. Enter. So this is the line, and now I need to take that line into Grasshopper. So I go to params, geometry, curve, right click, say set one curve, select it. Okay, and now we need to find the distance. So we again go to pull point. So we go to vector point, we say pull point. So the points are all of these points coming from divide curve, and the geometry that I want to pull it to is this particular curve. Super simple. Okay, then we got to remap it. So we go to math, remap all of these distances. Then we need to take bounds, but before the bounds we need to add flatten. So we go to set, flatten the tree. So you flatten the distances, otherwise it will not act for the entire set. It will act as separate sets, and then we will create our own domain. So I say construct a new domain. Okay, so now we take graph mapper, right click, take any graph you want. I will stick to sine. Now we want to move these points in x direction. Okay, so we use this as the distances. So we go to transform, Euclidean, we say move all of these points using this graph with a vector of x. So we go to vector, unit x, connect the graph mapper here and connect it to motion. Okay, there is a slight movement. Of course, there is a slight movement, but it's not profound because we haven't increased the number. So what I will do, I will add a multiplication factor here. So you see, it's very similar to the first script that we did today. Now we are just combining with attractor. So we go to math, we say multiplication, multiply these numbers by any number that you want. Now, ideally, the gap between these two lines is 100. So don't go with a number of like 200, otherwise they will intersect. So let's say I say a number like 75 or 60 is fine. So then I connect this to B and then I connect this to the factor. And now you will see that the points have moved. Amazing. Okay, and now you also see there's the influence of this attractor. Okay, so you see the points are near here, and as they are going, they're becoming far and far. Okay, let's join these points. So let's go to curve, spline, and let's say interpolate, and now you see, amazing, so beautiful. So also I want to explain now that why don't we flatten here. For example, let's say I flatten it here. You see how they all start joining each other because they are not in separate batches. So that's why I told you that don't flatten in the beginning, flatten where you want it to be and try to retain your original data set as much as possible. Because if I would flatten in the beginning, they would all come together and they would all join, and that's not helpful. Okay, now let's move this, let's move it, see what happens. Nice. Oh, I absolutely love it. You see, because of the attractor curve that we have there, the pattern is kind of flowing up, down, and down. How beautiful. And then what we will do is now I will change the location of this. So you will see, make it here. See the pattern changes. If I rotate it, move it, okay, you will get n number of iterations of the design. Okay. And now I need to convert this into surface because like I told you, for comfy, it's not easy to understand what is, because it will not know where is the depth, where is not the depth. Okay. So it's simple to create surface between two lines. Whenever you have two lines and you want to patch it, for example, let's say I have this line and I have a line like this and I want to create a surface in between. I use a component called ruled surface. Here you go to surface, freeform and a ruled surface, and it has only two inputs, which is what is your curve A. So I will say all of these interpolated curves, and my curve B are these lines. Okay, so I'm gonna move this a little bit like that, so I can connect the line geometry here, and right now you see what has happened. Oh my god, what is this? That's because one of the data set is grafted, the other is flattened. So we need to add graft here, or we can flatten this. Either way is fine. So let's go to set, tree, graft the tree, connect all of these lines to graft so they become separate. And if I connect it, amazing. Okay. So always see that the data matches visually. If you see one dash, one straight line, that means one is grafted, one is flattened. It will not work. Now here, there's one problem. The problem is it kind of touches here, and I don't like that. I don't like that it touches here somewhere. Okay. If you don't want this to touch, you can always remap number, or what I can do, this is a hint. I can increase this so the gap increases. Okay. Don't tell anyone. It's a super secret. Okay. So now you see they're not touching each other. As simple as that. Because now what I made, I said, okay, the limits can't be 0. The new limits has to be 0.1 because I increased by 1 square, and maximum can be 1. And if I make it more, we'll see. So now you can change whether they intersect or they don't intersect. I love finding these kind of tips and tricks which make my design process much faster. Okay, and that's how I made that particular pattern. So let me connect custom preview to it so you can see it better. And now you can increase the graphs, you can decrease the graph, you can change. However, how amazing does this look when it moves? See, motion graphics reminds me of motion graphics. Okay, and again, if whenever you start seeing these not smooth, what you do, you increase the count value. Right now they are 10. You see here how they have been jagged or staggered. If I make it, they become smooth. Okay. So if you feel like the pattern is a little bit not smooth, you can always increase the count because that is the number of points that you have. Okay. The more the point you give, the better result it creates. Okay. And then add whatever attractor you want. You know, I can maybe add a circle here and say set multiple curves. This one, enter. And now it has influence of both. So if I move this here, you will see it has influence of this particular circle as well as this particular line. So if I move it closer, you will see it is influencing this part and circle is taking care of the next part. So I can push this here, can push this here. Oh, I am absolutely loving this pattern. Damn, this is nice. It is so cool. Okay, I love it. Love it. Need to render this. Oof, beautiful. Absolutely beautiful. Okay, so you can create, you can go tweaking and creating multiple lines and things like that. If I keep on going, this video will go on for days. So you understand how Graph Mapper works and why we are using it. Because if you only use a curve or a point, it does not add much effect to it apart from that. Because if you want to imagine this pattern only with point and curve, I have absolutely no idea how to get this. But with Graph Mapper, it is super simple. Okay, so I hope you learned how to use Graph Mapper with Attractor. I know I said that we will be making 3D patterns in this particular video, but this video has already gone a bit longer than I anticipated. So I'm going to cut this into part A and part B. So this is the part A where we looked at Graph Mapper with an Attractor. And in the next video, we'll be looking at how to morph these 2D patterns that we created in the previous video and this video on a 3D surface. Okay. So I hope you like this video. Thank you for your time. Please do everything that YouTube suggests again, that is like, comment, share, subscribe, and I will see you in the next one. Thank you.